Okay, so let's get started with today's discussion. Today, we're going to be doing a full run through of the virtual laboratory experiment 1, chemistry and measurement. So first, let's talk about where to find this content in Canvas. So here we have the course Canvas shell. We are looking at the laboratory module, and the first few labs that we're working on include experiment 1 and experiment 2. We're going to focus on experiment 1, and I'm going to open up that lab page. So this is what the lab page looks like. It has the experiment title, some recommended reading and practice, as well as some required reading, and an introduction section. I'm also going to pull up the experiment 1 in the lab manual. So this is the lab manual that we're using for this course, and I've flipped to the experiment 1 page. It has some information on the experiment as well as an introduction section. I would encourage you to read both of these introduction sections. If you need a discussion of the lab as well as the discussion of the lab calculations and the background, I have prepared a pre-lab lecture in the course Canvas shell. So now that we know where everything is, the first thing I'm going to do is I'm going to set up and get my lab report sheets ready to go. So the lab has an introduction section, and then we're going to scroll down, and there's a discussion of the background for this laboratory. Additionally, there's an experimental procedure, which we will be referencing momentarily. There are some pre-lab study questions. You do not have to complete them, but they're good practice as getting you familiarized with the content and concepts of the lab. And here is the important part. This is what you're going to be submitting for this lab experiment, the Lab 1 report sheet. So there are various parts, each with a given letter and number. And you're going to want to pay special attention to these letters and numbers as these reference the part of the experiment that we're going to be filling in as part of the report sheet. So there are various parts: A, followed by a question, B, part C, and then there are some questions. So you're going to be turning all of these completed parts in as a Word, PDF, or photo document to the course Canvas page. And you're going to be submitting that into the Experiment 1 report submission page. Okay, so again, let's go look at our lab manual. So what I've done is I've taken all of these lab manual parts, and to make it easier for us to follow along, I have placed them onto my virtual notebook. This is done in OneNote just by taking a screenshot and moving the screenshots over. You can also print out the pages or annotate on directly and take a photo, whatever method works, depending on if you have a digital or hard copy lab manual. As long as the report sheets are filled in, you're good to go. So now that we have our report sheet, we're going to, of course, fill in our name, section, instructor components, and we're going to get started with looking through each part of the experiment. So as we start with part A, we're going to find part A in the experiment page. So the experiment page will have all of the data, be it photos, data tables, or in some cases videos for later labs that we're going to be using to write down and collect our data and observations. So I'm looking through, we're in the introduction section. This is just some background information. And now we're into the experimental procedure. The experimental procedure is the key part of each lab that we're going to be looking at, and this is how we're going to collect our data. So for part A, measuring length, we found it in the lab page, and we're also going to find it in the lab manual. So we have part A, measuring length. So we're going to be taking some measurements here. Now, because this is a virtual lab and we may not have all of the equipment needed at home to complete these experiments, there is an alternative procedure for this lab. If you don't have a centimeter ruler, please follow this procedure and you'll attach the completed data on a separate sheet. So we have these data tables that we're going to be filling in because we don't have a centimeter ruler in this example. We're going to be looking at this alternative procedure and we're going to be filling in our data. So if we go to our report sheet and we go to add some drawings here, for the measuring length section, all of these parts are going to be replaced with the alternative procedure. So we're going to leave these parts blank because I don't have a centimeter ruler. If you have one at home and you have the materials to complete this part at home, you're welcome to do this part. Okay, so let's look at the part A alternative procedure. We have a series of photos that are provided, and we're going to take some length measurements. So let's do that together. So we have the vertical length of a paper. So to open up this image, I'm going to open up this link and view this PDF. So we have a ruler available in front of us, and this is a centimeter ruler. We're trying to measure the length of a piece of paper, and we're going to be taking a measurement. So as always, first things first, we can see that we're somewhere between 27 and 28 centimeters. I count the number of graduated tick marks as 5, 6, 7, 8, 9, 10. So there are 10 ticks, and these 10 tick marks take us 1 centimeter of distance. Thus, 1 tick mark corresponds to 1/10 of a centimeter, or 0.1 centimeters. The reason why I'm analyzing the value of a tick mark is both to take my measurement in terms of certain digits and to estimate an estimated digit. So for our estimated digit, we can estimate up to 1/10 of a tick, or 1 decimal place past the smallest graduated mark. So we take 0.1 centimeters over 10, and that gives us 0.01 centimeters. Okay, it looks like we're pretty much right on the line. Let me erase this mark just so I can see that a little better. It looks like we're pretty much right on the 28 centimeter line. So we'd write it as 28.0 for our certain digits because we can report certainly up to the 10th place, and then we're going to estimate to the 100th place. So I can write this as 28.00 centimeters. There will be some variation in your measurement depending on who's taking the measurement. The estimated digit will change slightly. That's more than okay. And in fact, that's part of the point of one of the later discussions in this lab, to show how you will see some variation in your measurements, often associated with variations in the estimated digit and how you estimate that last digit of your measurement. Okay, so I've taken my measurement now, and where am I going to put that measurement? Well, I'm going to place that measurement in the corresponding section. So I have my report sheet. The length will be 28.00 centimeters. Again, we have a number with all the significant figures as well as the unit. Okay, so let's keep going with this process. We're continuing on with our table. And again, you can find this table in the lab page. It has all of the photos, videos, and other data tables that you're going to be using to fill in your report sheets. So let's look at this line 1 now. Okay, and again, we're going to have to take a measurement. So first things first, let's just do a check to make sure we have the same graduated marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 ticks in 1 centimeter. So we know that, let me erase one moment. So we know that 1 tick corresponds to 1/10 of a centimeter. And we know that 1/10 of a tick corresponds to 0.1 over 10, which is 0.01 centimeter. So we're working with the same ruler, so we can report the same certain digits and the same magnitude for our estimated digit. Okay, so we see that we're pretty close, 1, 2, 3, 4. So we're pretty close to the 4th tick mark. Not quite there. So I would estimate this to be about 4.3 because we're in between 3 and 4, and we're past 3 but not quite at 4. So our certain digits are 4.3. And then let's estimate one more digit. So 4.38 centimeters would be a more than reasonable measurement for the length of this line. Okay, let's take this measurement and let's again put it into our report sheet. Okay, so let's look at the next line. Again, we're just going through this table, which has all these images in the experiment 1 page. So again, same ruler, so we can follow the same rules for certain and estimated digits. So we're between 7 and 8. We're 1, 2, 3, 4, 5 tick marks out. So we're somewhere between 5 and 6. So I'd estimate this to be about 7.55 centimeters. Again, certain digits are these first two. The estimated digit is this last digit. Okay, so let's transfer this reading, transfer this measurement onto our report sheet. 7.55 centimeters. Okay, now we're ready to look at our third line. Okay. So let's open up the third line here. Let's take a look what we have. Okay, so let's take a measurement once again. So let's break out the annotate tool. So we're somewhere between 10 and 11. And in this case, we are 1, 2, 3, 4. We're pretty much right on the 10.5 mark. So I'd estimate this to be 10.50 centimeters because we're pretty much right on the 10.5 graduated mark. Again, we still need to include this 0 because we need to account for the estimated digit, because the number of digits that you report tells the reader what kind of instrument you're using to take a measurement. Okay, so let's transfer that over. So 10.50 centimeters. Okay, perfect. So we've completed part A. We've taken all of these measurements. Now, let's look and see what we have to do next. We have to answer a question. How does your value of the line length compare to the other students? And this would be a great opportunity to use the discussion forum. So you can take the table that you have completed as part of this lab, and you can share the measurements that you've taken with your classmates on the discussion forum. To show everyone where that is, if you go to the course Canvas page, there are multiple discussions. You could post it in the week 2 discussion forum or the week 1 discussion forum, and you should see multiple students posting. Okay, so after you talk to 2 other students and you compare your length measurements to the other students' measurements, you'll have completed this part that requires the discussion. Okay, we have one more thing to do for part A. we have to answer discussion question 1 in your laboratory manual. So let's find discussion question 1. In this case, it's labeled Q1. What digits in the measurements for the line by other students are the same as yours and which are different? So let's look at an example. Let's suppose that we've collected some student data. So suppose student 1 had the following measurements in their data table. So for their paper, they reported 20.01. For line 1, they reported 4.36. For line 2, they reported 7.53. And for line 3, they reported 10.48 centimeters. So we would take a look at our measured values and the students' measured values. And one thing that I notice consistently is that the last digit appears to be different. So if I were answering this question as a student, I would say the certain digits are the same, but the estimated digits, which are the last digits in the measurement, are different. Now, you can phrase your response in many different ways, and you may see something different when you compare your measurements to other students' measurements. The key thing is I just want you to talk about the data that you collected and the other students have collected and try to draw a conclusion from it. Okay, so we've filled in this first part. Let's move on now. Let's keep going through our experiment page. And let's look at part B. So for part B, we're dealing with measuring volume. So let's take a look at what we have to do for part B. So let's find it in the lab manual. So in this case, we are taking measurements for the volume of a liquid. So we have 3 spots for that. And then we're also determining the volume of a solid via water displacement. So let's find part B in the lab page. And as you can see, we have 3 volume measurements to take and a water displacement study to conduct. Okay, so let's get started on that. Again, I have our lab report sheets ready to go, and we'll be filling in the data into the report sheets. Okay, so for our volume readings, I'm just gonna note that we have 1, 2, 3 volume readings to take, and we're gonna place them into this table. So let's start with the first graduated cylinder. Okay, and once again, we're gonna break out the drawing tool. Okay, so first things first, we need to figure out the value of a tick mark. So between 50 and 60, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tick marks. So if we have 10 tick marks corresponding to 10 milliliters, which is the distance of 60 minus 50, from here, well, the volume difference. So 60 minus 50 is 10. And then 1 tick mark corresponds to 1 mil, 10 over 10. And we know that we can estimate up to 1/10 of a tick mark, which would be 1/10 of a mil, which is 0.1 milliliters. So we just have to be careful that we're not over-reporting. The next thing I'm going to do is I'm going to highlight the bottom of the meniscus. Remember, we measure from the bottom of the meniscus at eye level. So that's why this view is shot with a camera directly at eye level to the liquid level. And from here, we see we're past 1, 2, 3. we're just past the third tick mark, ever so slightly. So we could write this as 53.0 milliliters. More than reasonable. You may see some variation in the estimated digits. So let's transfer that over now. So our first volume reading, 53.0 milliliters. Okay, let's move on to the next graduated cylinder that we're looking at. Okay. Let's see here. Okay, let's break out the annotate tool. And again, this is a different graduated cylinder. So again, we need to verify the value of a tick mark. Okay, so from 110 to 130. So take us 20 milliliters of volume. It takes us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That takes us 10 tick marks. Thus, one tick mark corresponds to 2 mils, and thus a tenth of a tick corresponds to 2 over 10, which would be 0.2 milliliters. Now, it's important to note that your estimated digit for this measurement must be a multiple. It must be even, because we cannot report more precisely than a tenth of a tick. And because a tenth of a tick is even, our estimated digits must be equivalently even. This is a minor thing to very carefully consider, is that whatever your value for the estimated digit is, if it's in the tenths or the hundredth place, you also have to check if it's not 1 to make sure that your estimated digit that you're reporting has the same multiple. For example, if I said 121.3 mils, this 0.3 is more precise than I can report. So instead, I would change it to something like 121.2, 121.4, just making sure that the estimated digit has the same multiple. In this case, making sure it's even. Okay, so let's take an actual measurement now. I just wanted to discuss that because this is something that can come up when taking measurements, especially with more unique graduated devices, such as the graduated cylinder you see here. Okay, I'm going to label the bottom of the meniscus, which is somewhere around here from what I can see. Okay. So 5, 6, 7, 8, 9. So we're between the, well, let's annotate on here. Remember from our discussion, each of these ticks are 0.2. So this would be 112, 14, 16, 18, 20, 22, 124, 26, 128, 130. So we're between 126 and 128 milliliters. This is why we do the analysis of the graduated marks, to make sure we know how much each of these little graduated marks actually represent. So we're between 126 and 128 milliliters. So in this case, it's pretty close to 127. So I'd report my certain digits. So 126. So my certain digits are in the ones place. And then I'm going to estimate one more digit. So 126.8 mils, 126.6 mils would also be okay. 127.0 mils would also be okay, as long as you have your certain digit in the ones place and your estimated digit in the tenths place. The key thing, the estimated digit in this case must be even. Must be a multiple of 2. So I'm going to take my measurement and I'm going to place it into my data table. So in this case, 126.8 milliliters. Perfect. So let's keep going with this. Let's look at our next volume measurement. Okay, so again, new graduated device. So we have to check. So the liquid layer is right here. So this is where our liquid layer is, and the bottom of meniscus is somewhere around here. Okay. I need to see this top region here because I need to figure out the value of a tick mark. So from 300, in between 300 and 250, that is 50 mils of volume. So these 50 mils of volume are going to take us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 10 tick marks to work with. Thus, one graduated tick mark corresponds to 5 milliliters, and a tenth of a tick, in turn, correlates to 5 over 10 mils. In other words, 0.5 milliliters. Okay, again, this time, our estimated digit must be a multiple of 5. So it could be 5 or 0, because that is the amount of precision we're allowed to report in our measurement based on our estimated digit. So we report to the tenths place, and that tenths place digit is 5 or 0. Okay, so we are pretty much a little bit below the 250 mark. So the bottom of the meniscus we're around here. Okay, so now that we have the bottom of the meniscus established, we can see we're between the 245 mark and the 250 mark. Because remember, each graduated mark, if we move up or down, we're moving up or down by 5 mils, because each tick mark is 5 mils. Okay, so now that we have that established, let's try to take a measurement. So we're a little bit below 250. So you could report this as 248.0 mils. That would be fine. 249.0 is also fine. 248.5 is also fine, as long as we're matching a certain and estimated digits. Generally, when you're dealing with these kinds of graduated devices with irregular tick marks or tick marks that aren't a multiple of 1, it can lead to situations where you're taking a measurement and there's inherently a little bit more uncertainty in what the actual value is. And you can fix that by going to a more precise graduated device. So I'm going to choose to transfer over this 248.0 milliliter measurement. There's some variation in your measurement. So let's transfer that over. Okay, so I've filled in the volume of a liquid part, and now let's look at the volume of a solid by displacement. Now, the calculations for this part are discussed as part of the pre-lab reading in the lab page as well as the lab manual. So if you wanted a full run through, there's a discussion of the water displacement method provided in the pre-lab reading for part B. And I show an example calculation. With that said, let's do this water displacement calculation measurement. So we're going to record the graduated cylinder before solid addition and record the graduated cylinder volume after solid addition. Okay, so from 50 to 70, for 20 milliliters of volume, it takes us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Takes us 10 ticks. You can also import the image into an image viewer and upsize it however you please. So let's actually do that on the upsized image just to make it easier to see what's happening here. So I've taken the image and expanded it. So in this case, to showcase our work, to figure out the value, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to go 20 milliliters, it takes us 10 ticks. Thus, 1 tick corresponds to a value of 2 milliliters. And thus, a tenth of a tick corresponds to 2 over 10, which is 0.2 milliliters. So again, we can estimate up to the tenths place. Okay, so we have the 60 mark here. And we see that the bottom of the meniscus is somewhere between 60 and 62. So we can report our certain digits. So I'm going to report 60 and then an estimated digit of 0.8. As long as the estimated digit's even, you're good to go. So we have 60.8 milliliters. Okay, so let's close this image and let's take our initial volume. So we have 60.8 milliliters. Now let's take the volume of water and submerged solid. So that's the second picture. So I'm going to, again, open the image and just upsize it a little bit so that way it's easier for us to see on this computerized view. And again, we have the same graduated device. So 1 tick corresponds to 2 milliliters, and a tenth of a tick corresponds to 2 over 10, or 0.2 milliliters. Because we're dealing with the same device, we follow the same graduated tick mark rules. So you don't have to repeat the whole process of figuring out the value of a tick. We're using the same graduated cylinder. Okay, so we added the solid, the water level went up, proportional to the volume of said solid. Okay, so we're between 90 and 110. 1, 2, 3, 4, 5. So we're between the 98 and 100 mark. So I'm going to report this as 98.6 milliliters. Again, 2 certain digits, 1 estimated digit, and the estimated digit is even. Okay, so let's transfer that over. Okay, now we have to calculate the volume of the solid. So the volume of the solid corresponds to the volume of the solid plus water minus the volume of just water. So in this case, we take 98.6 milliliters minus 60.8 milliliters. And that in turn gives us 37.8 milliliters. Now, importantly, because we did a subtraction operation, we have to retain the same number of decimal places. 1 decimal place in each of our starting values, 1 decimal place in our reported value. Perfect. So we've completed the volume of the solid calculation, and we've completed part B. Let's move on now to part C. So part C concerns measuring mass. And in this case, there is an alternative procedure provided in case you do not have some of the materials mentioned in part C. So again, we have an alternative procedure with a series of images that we're going to take some mass readings from. So let's do just that. So again, for part C in our report sheet, instead of filling in these multiple tables, we're going to make a note that this has been replaced with alternative procedure. So we're going to leave these parts blank, and we're going to just do the part C alternative procedure, which involves us taking a few mass measurements. So let's do just that. We open up the lab page, and again, we have 2 images to work with. Let's start with the first image, which involves the mass of an empty beaker. So we're just going to record the mass reading. So in this case, you're going to take all of the mass reading values, and you're going to take all of the digits reported in this balance measurement. So we're going to write down 29.90. And the units, which are very important, are grams. Okay, let's do the second image now, which is the mass of a beaker plus water, and it's 34.96 grams. So I'm going to write down 34.96 grams. So we've successfully completed part C. Now, let's keep going through our instructions because there's still some more things to do. We have to answer questions 2 and 3 in the lab manual. So we open up the lab manual and we see there are questions labeled Q2 and Q3. So let's answer those questions. I'm going to be doing just a few of these because I believe answering these questions is important practice, but I'm just going to show you how you'd fill this in. So 4.5 meters, we have 1, 2 non-zero digits, so there would be 2 significant figures. 805 has 2 non-zero digits and a 0 that is both before and after a non-zero digit, so 805 would have 3 significant digits. Likewise, 34.80, these zeros, which are after a non-zero number and after a decimal place, are significant. They are denoting the given precision of this measurement, and thus we'd report a full 4 significant digits. To indicate the estimated digit is the last reported significant digit. So in this case, the estimated digit would be 5. For 4,500, these trailing zeros aren't significant, and as such, the 5 would be the estimated digit. You can repeat this process, and I want you to fill in the remainder of this table. I'm leaving the remainder of these question tables blank, so that way you can get some additional practice. But here we've completed the full overview of how to fully complete all of the report sheets and thus fully complete experiment 1. I hope this was helpful, and you'll see this completed report sheet as well posted on Canvas below this recording. So this concludes our run through of experiment 1, and we'll be continuing on with future experiment run throughs as the semester progresses.